Good morning. This is the online lesson for Algebra 2, Lesson Day 1. This should follow your Zoom meeting. After we've done the Zoom meeting, you'll do your exit task and then your warm-up assignment. Today we're going to talk about the difference between exponential functions and logarithmic functions. They are inverses of each other. Remember when we have been finding the inverse for the last couple weeks, we switch the x and the y. And then we solve for y. So the way we're going to get the y out of the power is by switching it into logarithmic form. There's some things about logarithmic form that are going to be very similar because it is the inverse of a exponential function, so we can see some similarities. In our exponential function, this b is what we refer to as the base. In a log function, that base will be here as well, written as a subscript, so it should be written below the line. The y is your power. That's going to go all the way over here, all by itself, on the other side of your equal sign. The solution from your exponential function ends up going to the parentheses here. So we say log base b of x equals y. For your assignment today, we're really just going to focus on switching forms from exponential to logarithmic. You're going to take this function, again, identify what is your base, what is your power, what is your solution. So base, power, solution. So when I write that into a log, it's log base, again, it should be a subscript, of 16 equals 4. When I go backwards from exponential, or from log to exponential, I identify the base, the solution, and the power, so that when I put that into the exponential form, it's base, power, equals solution. After you write it in exponential form, it should make sense. We know that 8 squared is 64, so that should make sense. When we look at the next example, we have base, power, solution. Again, when we write that into logarithmic, it's log base 3 of 81 equals 4. You do want to make sure that your base is a subscript. It should be a little bit smaller. It should be below the line. Similar size to how you guys were doing your powers on exponential. When I look at the next example, this is log base b. Solution is 64. The power is 3. So when we switch that into log form, it's our base of 4 to our power of 3 equals 64. Again, that should make sense. 4 cubed is 64. For the next one, again, we're writing from exponential into logarithmic. Here's your base, power, solution. So when I switch forms, it's log base 10 of 10,000 equals 4. Now there's two types of logs that our calculator has stored for us. That is our common logs, which is anytime we have a log base 10, we just drop off that base of 10 and write it as just log of x. So it's implied that anytime we see a regular log that it is base 10. This is what we use for identifying the Richter scale. This is what they use for most scientific notation, but the Richter scale is what you use for earthquakes. And anytime they say like our number system is base 10 or those kind of things, those are all referring to this base of 10. Again, it's kind of like in a square root. We don't put the number 2 there. We just assume that anytime you see a square root, it is always the square root. And then if we want to change that, we change it to the cube or whatever. It's similar to this. If there is no base, you write that as base 10. For the natural logs, that's another one, and this is a new vocabulary word for us, is this definition of e. E is an irrational number, similar to pi, in that it's a non-terminating, non-rational zero. It is going to be extremely important in all of our financial issues that we deal with. So instead of, again, writing log base e of x, we just write it as natural log. And anytime we see natural log, we know that that is going to be base e. These positions are on your graphing calculator, and we'll refer to those in the Zoom meeting today in terms of where you can find those. If you do not have a graphing calculator, if you turn your cell phone sideways, you should see both a log base 10 and a natural log button on your calculator. So what I want to do and what I'll walk through with you guys is how to use the calculator at this point. So the first two are just log base 10, 4. So you can go ahead and type that directly into your calculator as log of 4. You should be able to match these decimals. Again, I just wanted you guys to kind of practice where these notations come from and where these decimals come from. When you look at example 3, natural log of 1 should be 0, and natural log of e is 1. So those are kind of two of your basic facts having to do with log functions, and we'll talk about why these are true soon. Again, remember that natural log is equal to log base e. So what you're really looking for is e to the power of 0 equals 1, and we know that anything to a power of 0 is 1, so that's where that one makes sense. Now, if we do not have something in base 10, we have to get it into base 10 by using what is called the change of base formula. And the change of base tells us that we are going to take log base b of a, and that base can be any number that we need it to be. And we're going to take log of a divided by log of b, and that's going to allow us to use the calculator. That puts it into base 10 for us. On the next one, I have log base 1/3 of 81. Again, we're typing log of the old number divided by log of the old base, and that's going to get us a value of -4. As you guys look at these on the computer screen, you should be pausing the video at this point, trying these in your calculator. Make sure you know how to use your version of the calculator. For our last example, I wanted you guys to know that you cannot take the log of a negative number. If you type log of -12 into your calculator, it should tell you error or no solution. When we get into graphing later this week or beginning of next week, we'll talk about the domain of a log function. But the domain of a log function is that x has to be greater than 0. And we'll talk about the reasons behind that as we get into the graphs. But because of that, you cannot take the log of a negative number if you try to use your calculator. So I'm going to have you guys try these on your own. Again, at this point, you guys should be pausing the video on YouTube. You should be going through each of these examples on your own, making sure that you can switch forms from exponential to logarithmic and logarithmic back to exponential. Now, I did show you guys the form on the first page. Just real quick, remember, I'll use a different variables here because we talked about how it was a base to a power equals a solution. So when I take the inverse of that exponential and put it into a log, it's log base solution equals power. So we can kind of look at those variables, and what we can do as we get started is actually go through the examples on the previous slide where I identify the base, the power, and the solution. and that will help me figure out how to write that as a log. And the log one, again, go through and identify this is your base, this is your solution, and this is your power. So you can see how that log will transfer into an exponential function. After you've paused the video and attempted these all on your own, as you press play again, you'll notice that all of your solutions are up here. Double check your work. Again, we'll be going through this in the Zoom meeting today if you have any additional questions on these topics. So now that you've completed the Zoom meeting, what you should now do is go to the link and complete the exit task. That's how I'm going to be taking attendance. Once you finish that exit task, you should go right to your WOM app and complete that assignment. Remember that school should take the same amount of time as if you were in for a block period, so you do want to take all of this time possible to go ahead and just finish the lesson. Also remember that this information will not be retaught when we come back to school. And the next time I see you will be Friday morning at 7:30.